Let's now move to a Java virtual machine and code access security. I'm talking about the .NET framework. Both technologies allow granting permissions to programs. As we already know, a process doesn't define a security boundary. A solution that can effectively replace this is the code access security mechanism. Both virtual environments enable granting permissions to programs that are independent of the user permissions. This means that regardless of the user account used to launch a program, if loading data from the main folder on the C disk is disabled for the program, it will throw up an exception. An administrator or program developer grants code permissions without regard to the user account permissions used to run the program. The mechanisms, of course, are overlapping. To run a program, you would need to have appropriate privileges, but once a program is launched, it executes its own additional permissions. How are they created in Windows? With the .NET framework, a program's permission set is assigned according to the level of trust that it's granted. We'd need to identify a program, read its label. Next, we'd need to authorize all operations executed by the program. An attempt to execute a disallowed operation will result in the error you can see below. Code access security is treated as a security boundary. Microsoft reacts to all attempts to cross the boundary by issuing an appropriate critical security update. The mechanism for gaining code permissions is complicated. To simplify it, permissions are created in several ways. First, a program can belong to a zone. It can, for example, belong to the Internet or Intranet zone, which means that it can be downloaded from a LAN or external network. A program can also belong to your local computer zone. It will then be granted a different trust level. The levels are governed by the site of origin of a launched program. Beyond that, we'll also have credentials, or a program signature. These two mechanisms will overlap to build a resultant program permissions list. If this mechanism is to be used to its full potential, software developers must request granting appropriate permissions to a program either declaratively or procedurally. The top listing in the slide above shows a demand for granting permissions to read a file. The below listing shows the explicit specification for a program to not execute some operations. The effectiveness of protecting an operating system is underpinned by risk management. To manage risks in a purposeful manner, you have to be aware of the threats that you may face and know the inbuilt system security technologies. A basic concept that relates to classifying the technologies is a security boundary. A security boundary allows you to control data flow between a code and another code. There's fewer boundaries in a system than it could seem. One boundary is set by the computer itself. The others are defined by a system or by the user role. Over the past 10 years, only one new boundary has emerged. A boundary set by a virtual machine, or a Java framework. Within the domain set by a boundary, malicious processes are not controlled. It's vital to plan your security solutions with this in mind. Thank you.